Hello students, yesterday I told you the numerical questions up to 17 and today I will take the numerical questions of the Neet 2020 from 18 to 26 and I told you that all these numerical questions are based upon your understanding concepts and the application. So you all watch the video completely. Only then you can understand that how to apply the formula. And also it is necessary to understand the language of the question, because sometimes what we understand is not correct. So we choose the incorrect choice, and because of that we get the negative marking. So you all watch the video, subscribe, share and like it. So now I am taking the question number 18. Question number 18 to this is 26. 18 to 26. Now question number 18. Assume that light of wavelength of wavelength 600 nanometer is coming from a star. From a star. The limit of resolution of telescope whose objective as diameter of 2 meter is. Now the options. Option 1 is 6.00 into 10 raised to the power minus 7 radian. Second, 3.66 into 10 raised to power minus 7 radian. Third, 1.83 into 10 raised to the power minus 7 radian. And fourth, 7.32 into 10 raised to power minus 7 radian. This is given the choices. What is given here? That the wavelength is given, that is 600 nanometer, and coming from the star, the limit of resolution of the telescope. And the limit of resolution of the telescope is always measured in radians. So first you must know the formula of limit of resolution. limit of resolution delta theta is equal to 1.22 lambda upon d. This is the formula. So this is your 1.22 lambda. Lambda is given to be 600 nanometer. 600 nano 10 की power minus 9. Diameter, this is given to your 2 meter. So this is now your 2. So now by 2 this will cancel 0.61. Then just you multiply. This is now 6 and 6 36. So this is so much into 10 raised to the power minus 7. lambda, and this is now your 366 minus 9. So 2 will cancel from here. 3.66 10 raised to the power minus 7. This decimal goes at this point. This is now so much radian. So just you put the value of lambda and put the value of d and find out, and you will get that this value matches to this one, the second option. The right answer is second. This is now second. And now question number 19. A wire of length L area of cross section A is hanging from a fixed support, is hanging from a fixed support. The length of wire changes to the length of wire changes to L1, whose mass M is suspended when mass M is suspended. From its free end. The expression for the Young modulus is the expression for Young's modulus is, now the options. Number 1, mgl upon A into L1 minus L. Second, mgl1 upon A L. And now third option, mg And now fourth option, that is your mgl upon al1. Solution. We know that the Young modulus Y is equal to mg upon A into delta L into L1. This is the formula. And what is given here? Changes to L1. Length of the wire changes to L1. This means that the total length of the wire is given to be L1. So this is how that this is the support, this is the wire, its length is L. And when a weight is suspended from this, then its length becomes this now L1. This is L1. So this must be the increase in length. This is delta L. This is delta L. This so much is delta L. This so much is delta L. Increase is to L1. It means that total length is given to be L1 when the weight is suspended. Then to find the change in length, it's L1 minus L. And if it would have given that the changes by L1, then what is there? That this delta L is given to be L1. So changes to and changes by. There is difference between the two. Changes to means you are given this total length. Changes by means this is given the L1, the delta L, the increase in length. So changes to L1 means the total length is given L1. So this is now L. So delta L is equal to L1 minus L. And this L1, this length L1, this is given to be now L. So now here L1 equal to L and delta L equal to L1 minus L. So just you put, then you will get this is now your mg and this is L upon A into L1 minus L. So this choice matches to this number 1. So the answer is number 1. So this you have to keep in mind that where this is given to be changes to L1 or changes by L1. Suppose we say that this increases to L1. Increases to L1, it means the total length. Increases by L1 means the length increase in length is given here. So according to that you put the value. तो इसमें क्या है कि जैसे आपका यहाँ इतने से बढ़ती है इतना बढ़ जाती है, ये इसमें डिफरेंस है. So this is what the question number 19, and now I take question number 20. Question number 20, the energy required to break one bond of DNA is 10 raised to power minus 20 joule. this value in electron volt. In electron volt is nearly now options. First 0.0006, second 6, third 0.6, and fourth 0.06. This is the direct question. You have to convert this joule into electron volt. So we know that this 1 electron volt equal to 1.6 into 10 raised to the power minus 19 joule. This is so much. This is the relation between electron volt and the joule. This is given joule, you have to convert this in electron volt. So you have to divide this value by this one. Therefore 10 raised to the power minus 20 joule equal to 10 raised to the power minus 20 upon 1.6 into 10 raised to the power minus 90. This is to be so much. Then what we have? Just to simplify, this will cancel by this one. This is now 1. This is now your 1 point will again increase. So this remove this decimal. This is now 0. So this will cancel to by this one completely. Then we are having this 1 upon. This is so much. So just to divide, you will find 0.06. So much electron volt. So the right answer is given here. This is now fourth. You have keep in mind this relation. 1 electron volt equal to so much joule. Then you can convert electron volt into joule and joule into the electron volt. If electron volt is given, then you directly multiply this value, and if the joule is given, you have to convert in electron volt. Then you divide by this value, as I have done here. So the answer is now fourth. Answer fourth. Now question number 21. In a certain region of space, with volume 2 meter cube, 2 meter cube. The electric potential is found to be is found to be 5 volt throughout. 5 volt throughout. The magnitude of electric field. The magnitude of electric field in this region is, now you are having the options. So now your first option is 5 Newton per Coulomb. Second, 0. Third, 0.5 Newton per Coulomb. And fourth, 1 Newton per Coulomb. This is given to you. Now first you read the question carefully. What is given here? In a certain region of space with volume so much. You are given the volume of the space. The electric potential is found to be 5 volt throughout. It means that within this volume, the electric potential is so much at all the points. It means that in this region, the electric potential is uniform. So when electric potential is uniform, this is just like you suppose that you are given a sphere, a conducting sphere, and if the charge is given to it, then the electric potential inside the conducting sphere is same. This does not change. And we know that when this V is equal to remains constant, the electric field will be equal to 0. This is the case. This question has been just the language has been twisted. Here this is not given the conducting sphere. Otherwise, every student have to will understand it to be that this is a direct application. So what is given here? In place of conducting sphere, he has given the space and he has given the volume. There is so much volume. In this volume, at every point, the electric potential is 5 volt. So how to find this? Either you can do it 0 directly. This is a question 0. Also, you can prove it by this formula. Solution E is equal to minus dV upon dr. This is the relation. When V is constant, then dV is equal to 0. So this is equal to 0 because dV equal to 0. So electric field will come out to be 0. So also, if you do not have the idea of the conducting sphere, even if you know this formula and you are understanding this, that at every point the electric potential is so much, so change in dV is equal to 0. This dV is equal to 0. Change in potential. So now right option is 0. This is now second. This is now answer. Now this is your 21. And now I take 22. Question number 22. The mean free path for a gas with molecular diameter D and number density N can be expressed as, now first option, this is now 1 upon root 2 n square pi square d square. Second, 1 upon root 2 n pi d, and third option 1 upon root 2 n pi d square, and now fourth option 1 upon root 2 n square pi d. These are the options. So first you must know the formula of the mean free path. What we study in mean free path, the formula is 1 upon root 2 n 1 upon root 2. This is your n pi sigma square, n pi sigma square. This is sigma is the diameter, but this is given what here, you are given the diameter d. So only confusing term is what, this d. So when we study in theory, what we have, mean free path lambda bar equal to 1 upon root 2 n pi sigma square. This is given sigma square. Now in place of sigma, we are given this the value of d. This is the only difference. Otherwise, this is the complete formula. What we have, this is equal to 1 upon root 2 n pi, and this is now your d square. Now you see that this is the right answer. So sometimes the notation is changed. This diameter can be written as is by the letter small d, by capital D, by sigma, etc. The terms can be used. So just you have to keep this value in this formula and then find the answer. So right answer is your third. Now we are having question number 23. An electron is accelerated from rest through a potential difference of V volts. Through a potential difference of V volts. If de Broglie wavelength of electron, if de Broglie wavelength of electron is 1.227 into 10 raised to power minus 2 nanometer. The potential difference is now options. First option is 10 raised to the power 4 volt. Second option is only 10 volt. Third option 10 raised to the power 2 volt. And now fourth option is 10 raised to the power 3 volt. 3 volt. So this is given here. Potential difference V, de Broglie wavelength of the electron is given. This is a direct formula. Directly use the de Broglie wavelength formula for the accelerated electron. Lambda equal to 12.27 upon square root of V angstrom. This we know. Lambda is given to be here. But what is confusing? 10 raised to power minus 2 nanometer. Sometimes students what do they? That they forget this value nanometer, and they directly put this so much value. Or they forget this value and directly they write down this nanometer. And some students think that this is not so much 10 to the power minus 2 and then this nanometer 10 to the power minus 9 and so much minimum wavelength cannot be for the electron. But so thinking is bad. We have not to think that what is correct or not. What is given in question, this is right. So this must be in your mind that what is given in question, that you have to write down the value here. This is given to be 1.227 10 raised to the power minus 2, then nanometer, nano, this is 10 to the power minus 9, this is now 12.27, angstrom, 10 raised to the power minus 10 upon square root of V, this you have to find. What do you do? First you remove the decimal, this decimals are given here, so this you by 1000, this decimal is given, so thus you keep this 2 zeros this area, this 2 zeros will cancel by this one is left, then this 10 raised to the power 10, this will cancel, here will be this 10 raised to the power minus 1, and this minus, this will cancel by this value. What is left? 10 raised to the power, this is now 10 raised to the power minus 1, this you take in the numerator, this will 10 raised to power minus 2. This is in the denominator. So this square root of V, this is given to you 10 into 10 raised to the power 1. So this is how much? Square root of V equal 10 raised to the power 2. Now then you have to find the value of V. So you have to square both sides. So V equal to 10 raised to the power 2, just you square it, then you will get V equal to 10 raised to the power 4, so much volts. This is the answer, 10 raised to the power 4. So what do you do? First you write down the values in a proper way. What is given in the question, this is the right one. You have not to think that this is wrong or something else. So you put these values and do the calculation. This arithmetic calculation must be very strong. And then you just find the value of V by removing the square root and you will get the answer. So our answer is, this is now first, 10 raised to the power 4. Now I take the question number 24. In a guitar, two strings A and B. A and B. made of same material, are slightly out of tune. Are slightly out of tune and produce beats frequency and produce beats frequency. 6 Hz. When the tension in V is slightly decreased, when tension in V is slightly decreased, the beats frequency increases to the beats frequency increases to 7 Hz. If the frequency of A is 536, no, this is 530 Hz, 530 Hz, 530 Hz. The original frequency of V will be, now the options are, first 537 Hz, second is 523 Hz, and now third is 524 Hz, and now fourth is 536 Hz. You are given the guitar, it has 2 strings of the same material and they will have the same length, and when they are out of tune and when they both the wires are sounded together, they produce the beats 6 Hz. So what we have, how to solve to this question? This is now wire A, this is now your B. So this wire A is given the frequency, this is now 536. Let its frequency is N and beats are given. Beats, this is now 6. So possible frequency N equal to 536 plus minus 6. So this will be your, this is now your 536 or 524 plus 536 minus 524. So 2 frequencies are possible. Now you have to confirm that which frequency is correct. For that you are given here that when the tension in V is slightly decreased, we know that the frequency depends upon the tension. it is directly proportional to the square root of tension. So when tension will decrease, the frequency will decrease. Frequency decrease means that the beats will also increase. So this is given of 536, this is now 524. So if this frequency the beats are increasing, then this frequency is not possible, because 7 beats cannot take place when this 536 is there, because this will decrease, so this will be less than 536, and in that case the beats will not be equal to 7 hertz. So we leave this value. Now remaining is 524. When the tension decreases, the frequency will decrease. When this will decrease, then the beats will increase. So beats will be 7. So in place of 524, this will be 523. And now the right frequency will be 524. So the answer is 5. This is your 524. This is given to be third option. 524. Always remember, I have taught about the beats, and I have also taught that how to find the right frequency of the unknown tuning fork. So if you go through that, you can find that how to find the right frequency of the unknown tuning fork. So this is what the answer to this question. And now question number 25. If 40 microfarad, a 40 microfarad capacitor is connected to a 200 volts 50 hertz AC supply. The RMS value of current, is nearly. Now options. First option, your 25.1 ampere. Second, 1.7 ampere. Third, 2.05 ampere, and fourth, 2.5 ampere. You have to find the RMS value. What is RMS value? Always remember, in all circuits which are connected with the AC supply, they all have the RMS value of current and the voltage. Here given this 22,000 volts, this is the RMS value, not the peak value. So in all AC circuits, the value of current and the voltage are always in RMS. So we have not to confuse that we have to find this is given the peak value. This is never the peak value. In our domestic supply of the power, this is the 220 volts and 50 hertz. So 220 volts, this is the RMS value of the potential difference. since you are giving the capacitance 440 microfarad, so first you have to find the that what will be the you have to find the XC. This we know, this is 1 upon omega C. So this now value of reactance is so much ohm. After finding this resistance, then you will have to find the current. This is equal to 1 upon 2 pi f C. Now you put the value. This is your FC. And now IRMS therefore is equal to VRMS upon XC. This is the formula from Ohm's law. VRMS is given here 200 volts. This is now your VRMS upon, this is now 1 upon 2 pi FC. This is so much. And now it will be VRMS into 2 pi FC. Now you put all these values. So IRMS, VRMS is equal to 200. This VRMS 200 into 2 into pi 3.14. F, this is now 50 hertz. And C, this is now 440 micro 10 to the power minus 6. Just to simplify to this one. So just you have this 0, 0, 0, 0. So this will cancel, this is now 2. Okay. 2 into 4, 5 into 4, 20, 20 into 4, 80. 80 into 3.14 into 10 raised to the power minus 2. So now just to simplify that this 0, this will cancel by minus 1 and multiply to this 8 4 the 32, 2 and 3, 8 and 1 11, 8 and 3 11, now 1 24 and 1 25. So 25, so this is now point is so much into 10 raised to the power minus 1. So what do you do? This you bring here. So this will be your 2.512. So much ampere. Now you see the option. Which is the option? This is not 25, this is not matching to this one. This is not matching. This is not matching. This is only matching. 2.5. 1 is not written here, no problem. Just you have done 2.5. So what we have is IRMS. This is not 2.5 ampere. This is so much. So now your option answer is what? This is now 4th. This is now 4th answer. Okay. So you have to find the value of XC, the reactance of this capacitor, and then just your calculation must be strong one. I am one more telling you. If you do the mistake in the calculation, you cannot find the right answer. And you have to match this value with this all the options, and this is only the 2.5 here. This is not so much. Remaining is not matching to this one. So our right answer will be this 2.5 ampere. And now question number 26. The The increase in width of depletion in depletion region in a PN junction diode is due to number one, increase in forward current, second, forward bias only, third, reverse bias only, and now fourth, both forward and reverse, both forward and reverse bias. This is a theoretical question given directly. The increase in the width of the depletion layer, depletion region in a PN junction diode. You have studied the forward bias and the reverse bias. In the forward bias, the region always decreases. There is no increase at all, because the applied electric field always opposes the internal electric field. So the depletion region becomes less. In case of reverse bias, the applied electric field always supports the internal electric field inside the depletion region. Because of supporting nature, this will expand. So the depletion region will increase. Except to this forward and reverse, there is no other way of increasing to this one. In the biasing case, otherwise it may be increased by any other way also. You have since biasing is given here, so you have to see that the forward bias, this is not possible, this is also not possible, only reverse bias, this is not possible. So only the right answer is third, the reverse bias only. The answer is your third. This is the correct answer. So students, I have told you this 9 questions today, and the next 9 questions I will take tomorrow. And you just see that I have explained these answers very clearly. You have to understand them, and then you also try to solve the similar numericals. Numerical must be simple and easy, depending upon your knowledge, depending upon your concept, depending upon the application, and nothing else. You have not to go through the complicated, very sophisticated and very difficult questions. You leave all these things. You just have the simple questions which are based upon your knowledge. So what we have studied, that must be applied here. Students are very much confused that we would have given to be so much difficult questions. So they try to the difficult question. They always leave the small questions. The short and very short questions they leave out. They do not see these questions, never. They never see these questions. This is what the drawback. This is why that the students are not getting the right answer and they are not being selected in the Neet exam. So difficult questions You have not to see them, only short and very short MCQs questions which are just based upon your application on the concept or the topic. So you all like, share and subscribe this video. Thank you very much.